We're now going to talk about extended finite state machines. Recall the previous example of the garage counter. When we looked at the finite state machine, modeling the actual model actor of the system with a notation that was a little bit awkward because the parameter m can be very large, and that implies to jump through all the states manually. So that creates a very informal notation. With an extended finite state machine, we extend the state machines with variables that may be either read or written. In an extended finite state machine, you will now have to describe, or actually very carefully list and declare your variables and what their domain, the inputs and the outputs as well. Variables are modified below the word/output notation we had before, using this count equal count plus 1 type of example. I will insist again on the notation. We'll have the word, the output, and the variable modifications. Variable can be used also in the words to understand a transition or to decide if we make a transition or not. So here's a general notation for extended state machines. We'll have to make explicit declaration of variables input and outputs to help distinguish between the three. And the word/output action and the set action will always be represented using the same formalism, this kind of triangle representation. Let's look at a little bit more complex model. I will not go through the details of this specific model, but this represents a traffic light controller at a pedestrian crossing. And you will see that, first of all, we have the definitions with the variables, inputs and outputs. Variables is count, that ranges from 0 to 60. The inputs, which is only the pedestrian, is a pure signal, and same goes for the output, which will be signals to trigger the traffic lights. We have our input in our initial transition that goes into red, and you can see already in this state that we have a default transition that is represented. Why do we have the default transition? Because we do have an explicit set action associated with that. So we do not have the word/action, because this is implicit, it's when no other transitions are taken, but we do need to have a specific definition for our set action, which is in that case an incrementation of the count variable. The rest is fairly standard. I will invite you to look at the grid state, for example, where you don't have any out action, which is different than the transition, or I should say that the default transition for the green does not have any output action. However, all the other transitions, or most of the other transitions from a color to another, will have a specific output action with a sig, y, r, or green signals. One last thing that is important to consider on this finite state machine, it is a time-triggered model. This time-triggered model will react on a tick of a clock, which will be linked to the counter. The counter will count time, the number of ticks in that particular case.